All right, I want to go over the check your understanding. If you didn't have time to get all the way through it, maybe just kind of set your packet off to the side for now while we talk about it and try it again on your own time, because it's really, really, really important that you are practicing doing these things, especially when it comes to some of the language of statistics. Making sure that you can remember some of the statistical language and use it appropriately is really important. So there, where it says LT number 3, learning topic number 3, I wrote in blue. I circled the SOC, and then for variability, I wrote S, because this helps me remember that when I'm supposed to be describing a distribution, I need to describe the shape, whether or not there's any outliers, the center, and the spread, which is variability. But I think SOCS sticks in my head better than SOCV. SOCS is what I remember, so that I get my distribution labeled. And then you also need to include context. All right, on the check your understanding, your stem plot should have looked like one of these two. On the left-hand side, I have just a single stem plot. On the right-hand-ish side, I have a split stem. Yes, sir?
I'm sorry, but can you help me understand what a stem plot is?
A stem plot, absolutely. So with a stem plot, it is a way that I can show all of the values that are falling into certain buckets, basically. So I'm looking at all of the data. This one right here would be all of the collected data that is in the tens. We only had a single value in the tens. That was 14. And then this one right here shows me all the data that's in the 20s. It helps me make these bins or groups, and then I could use a stem plot. This actually looks a lot like a histogram, just flipped on its side. Does that make sense? With a split stem, my buckets are 5 wide. With just a regular stem plot, my buckets are 10 wide. So with a split stem, this is all the things from 10 to 14, and then this would be everything from 15 to 19.
All right.
From 20 to 24, from 25 to 29. Yes, sir?
So on a stem plot, can we put a 0?
Yeah, you can absolutely. And a lot of times we will need to start with some zeros because we'll have values that are smaller than 10, yes. You decide where to start and where to stop your stem plot based on where your data is actually falling. There's no need to write down a bunch of things if you have no data there, which is why I personally didn't include a 0 there, but it's not incorrect to include it. Make sense? All right, so this is, one of these two is what your stem plot should have looked like. This over here, do not forget to include a key. Super important that you include a key. I don't remember the exact year number off of it, but on the AP exam one year, students were instructed to make a stem plot, and it was actually written into the rubric for the readers, the graders, that if you did not include a key, it was points off. So I'm trying to make sure to stress anything that I've heard like that as far as feedback coming from other AP stats teachers. All right, down at the bottom, and I actually need to erase some of this because I didn't read my directions close enough. All right. So they asked me in part A to describe the shape. The distribution of points scored by U of M appears roughly symmetric. Especially if I'm looking at just the single stem plot. You guys see how I've got like a big bump of data in the middle with a little bit on either side of that? It has this roughly balanced appearance to it. Even with my split stem plot, I still have a roughly symmetric. The big bump of data is closer to the middle than on either the low end or the high end. Does that make sense? Okay. Are there any potential outliers? Look at the dot plot. Does any of the data from the dot plot look like it could possibly be an outlier? 14 could possibly be an outlier. 14, 37, and 38. These are, this one is a potential. small outlier. These two are potential large outliers. All right. We will learn tomorrow how to determine whether or not it actually qualifies as an outlier. But for right now, it's okay to just look at it visually and pick out the things that are possible outliers. What measure of center is most appropriate to describe the distribution? Would I want to use the mean or the median? Median. We do have some potential outliers. What do you notice about the distribution of the data, though? Like when I look here, even, it looks like they are potential outliers, but we also described our distribution how?
Symmetric.
Roughly symmetric. So whenever our distribution is roughly symmetric, even if I've got some large and small values, if I have a roughly symmetric distribution, I would want to go with the mean. Because if I have a very large outlier and a very small outlier, those should balance each other. If I only had outliers in one direction, that's one where I would maybe want to look at what is the potential effect here. So I would say the mean, because the distribution is roughly symmetric. All right. I need you guys to get very quickly, because we don't have a lot of time for the data collection part, very quickly into groups of 3. We've got 22 people in the room, so I will have one odd person out. If you find yourself to be the odd person out, find a group of 3 to join, and we'll have a single group of 4. What I want you to do in your groups of 3 is figure out together the total number of colleges that the people in your group are planning to apply to. Doesn't matter if you're not a senior, what are you thinking? We want to get a count. You don't have to necessarily list them out by name, but like, oh, I was thinking about IU, Purdue, and Notre Dame. So you would be thinking of 3. Another person in your group is like, it's Harvard or bust. So now your group total would be up to 4. I want the total for your group. Does that make sense? All right, I'm going to give you guys about 2 minutes to do this, because then we're going to move into the data analysis part, okay? So find a group of 3, decide together how many total colleges or universities you guys are thinking or planning on applying to, all right? Take 2 minutes and go. group right here? Do you have like a group number, or will you have it in about a minute? Okay.
I'm gonna do like 7.
16, perfect.
Which one?
Thank you.
Wait, did you ask?
Do you guys have a group total, or?
Yeah.
Okay, what's your group total?
17.
10?
I was close.
Do you guys have a group total for me?
15.
15. Do you guys have a group total?
17.
17. What's your group total?
17.
17. Okay. Do you guys have a group total for me? 7. And my group of 4, do we have a group total? 8. All right. An average of 2 a person. All right, guys, I've got our data set on the board. So I've got the data for the whole class collected here. We had 7 different groups. We have 16, 10, 15, 17, 17, 7, and 8. So we want to find the mean and the median for this data set. How do we find the mean?
Add them all together and divide by 100.
Add them all together and divide by, how many are we going to be dividing by here? 7, because we had 7 groups. So I've got 16 plus 10 plus 15. That's what, 30, 41 plus 15. So 56 plus 17 plus 17.
Where you get the other 50?
Oh, thank you. I wrote 15 twice. Thank you for saying something. It's hard because when I'm writing on here, I really am not trying to be a moron, but like I have to zoom in to be able to write, and that means I can't see everything else. So thank you guys for correcting me when you do that. 17, 17, 7, and 8. So 30 and 34, 64, 74, 84. I got 90? Okay. All over 7. So 90 divided by 7. I cannot do that one in my head, so I need somebody to grab me a calculator, and we'll take it out to, let's take it out to 2 decimal places for today. 12 point, you said 86 when we round? Okay. And then median. How do we find the median?
You gotta put it in least to greatest.
Yes, least to greatest. So I'm going to reorder this group up here. So 7, 8, 10, 15, 16, 17, 17. Since we have 7 groups, the middle value is going to be how far from either side?
3.
Well, I'll go 1, 2, 3 in, and then it'll be this guy right here, right? Because if I cross out, these would cross out, these would cross out, these would cross out. Okay, so our median is 15. Mean and median aren't super close together here, are they? No. Interesting. Okay. What is the range of the data? 10. Absolutely. Because I've got 17 minus 7, so the range is 10. Something I do want to make you aware of, just because it will be counted wrong if you do it. If you say the range is from 7 to 17, that would be incorrect. The range is one single numerical value, so you actually have to execute that subtraction in order for it to be considered the range, okay? Standard deviation. Have you guys ever heard of standard deviation before?
Yeah.
So we've like heard the term maybe?
Nah.
Does anybody know what it means?
She told me I forgot stuff.
Totally fair. I don't expect anybody to come in here with any prior stats knowledge, so that's fine.
Oh,
I know
is it-
sometimes it's been touched on in other courses, but sometimes it hasn't been. Yes, sir.
Isn't it like it's like the middle of the sections?
Sort of. Yes, I like the thought train that you're heading down. So what standard deviation helps me describe is how spread out my data is, how variable my data is. So that last piece, when we think of SOCs, S-O-C-S, shape, outliers, center, and spread, or variability, standard deviation gives me a way of describing that. It is going to give me the average distance of a data point away from the mean. So the average distance we are away from the mean. Here is how we find the standard deviation. First thing we're going to do is on the side where it says value in this table, we're going to take our class data, 7, 8, 10, 15, and we're going to list it out down that column. So right here, 7, 8, 10. Hold on, I want to grab some of these numbers here. See if I can get that guy. Come on, no. Whatever, it's not going to cooperate for me. All right, 12.86 was our mean. All right, 7, 8, 10. I'm sorry, I don't have it up anymore. Can you guys read me the rest of it? 15, 16, and then 2 17s. Okay, thank you. All right. We are going to find the distance from the mean. How would I find how far away each of these values is from the mean? Subtract. So I'm going to take the data value minus the mean. And I want you to actually go ahead and do that subtraction. I want you to write down the answer to that in that same box. So you're going to do 7 minus 12.86. And write down your total. And then 8 minus 12.86, and write down your total. I want you guys to do that all the way down. We'll check back in just a minute once you have those values. So far, so good? Are you guys getting the values that I got? Okay, please tell me if you're not. All right. We're going to take that value, so what I have in purple, and we are going to square it. After we square it, we're going to add it up. Why do you think it's so important that I square it before I add it up? What would happen if I just added up the differences from the means? It's not only going to be much smaller, it's going to be really, really close to 0, if not exactly 0. Because what I'm going to find is these distances on the negative side are going to cancel out with my distances on the positive side, and I'm going to end up with a number that doesn't really give me much information as far as how far away we are in either direction. So we're going to square it so that I have all positive values. And then we'll worry about square rooting things later, okay? So I want you to take each of these values and square them. please remember that when you square a value, it always comes out how? Positive. So even if you type it into your calculator and you forget your parentheses, you get a negative back, you should know better. Drop the negative sign. Yeah, if you don't put the parentheses on there, as long as what you write down on your page is positive. To be correct, should you put the parentheses in? Of course you should. How are we doing so far? You guys getting the same numbers that I got in that light blue color?
Yeah.
We are going to take all of those and we are going to add them. So we want to add all of those to get the total. All right. I need somebody to tell me if they got the same thing as me. I'm going to put my answer up here, but I just need a double check on my calculator skills here. I got 114.86. Is that what everybody else is getting?
Yes.
You got 76? I got 114.86. It is possible that I typed something in wrong, though. Let me check my numbers. 1714 twice. 9.86, 4.58, 818, 23.62, 34.34. All right. So that is the total of all of my distances from the mean squared. I want to find the average of that. How do I find the average distance from the mean squared? Divide it by 7, because we had 7 groups total. We had 7 pieces of data. So we're going to do 114.86, and we're going to divide that by 7. I got 16.41 when I round. So far, so good? All right. So a couple things before we go to check this. These values over here, let me find the right color to do this in. I'm going to do it in orange so that it stands out. Value, we refer to these as xi. Each individual piece of data, I didn't know it until I asked, so it is a variable. It's a value that can change. And for each group, So if I was going to talk about groups 1 through 7, it'd be x1, x2, x3, x4, x5, x6, x7, right? So xi is just telling me each piece of my data. Distance from the mean, what we're going to see there, and I just do not have room to write this, so I apologize. We're doing xi. So each individual piece of data minus x bar is how we're going to represent the mean. So that is my x bar. And then distance from the mean squared, the way I would represent this idea is inside parentheses xi minus x bar, and then I'm going to square those parentheses. So a lot of times we'll see things written out symbolically. I want you to know what it means because we've done the calculations. They're not difficult, but the way we talk about them and represent them in print can look kind of confusing. You guys okay with the notation there? At least reasonably so? Okay. So this guy right down here, this is the sum of taking all of my xi's minus x bar squared. So the way we indicate a sum is with this notation right here. That's the Greek letter sigma. It means I took a big list of things and I added them all up. xi minus x bar squared. So the way I would read what I just wrote in orange is the sum of the squared distances from the mean. And so this guy right here would be the sum of xi minus x bar squared divided by n, where n is the number of data points I had, or in this case it would be the number of groups. So this number in green right here, that gives me the average of the squared distances. But what I want to find from this is not the average of the squared distances. I just want the average distance from the mean. So how could I take this thing that is the sum of squared distances and use it to find the average distance? Take the square root, yes. So let's take the square root of that number. I'm going to take the square root of 16.41. You guys get that it's about how much? Yep. I got 4.05 when I did it on my calculator. That is the typical distance from the mean for any of our data points. So when I look at most of our group's data, our mean was 12.86. The average distance on either side of that mean is about 4 colleges. There are some groups that are further away than that, but most of our data falls within 4 colleges less, 4 colleges more. Do you guys see how that captures most of our groups? All right. I want to go and check this out in Statlet. By the way, this is my standard deviation here. That green number that we had over there when we summed our squared distances, this is called the variance. I just want you to know that we do have vocabulary terms for these different pieces, because when I talk about the variance, it's always going to be quite a bit larger than my standard deviation, unless my standard deviation is super, super, super tiny. But that's not very common. So the variance is before I square root it. Standard deviation is after I square root it. All right. Let's go to Staplet and see what they say, because in the summary statistics, it gives me standard deviation. So let's go enter our data there. I'll do it up on the screen so that we don't have to all get into that right now. I'm going to go here. What should I choose? Quantitative. How many groups did we collect data from? Just one. So one quantitative variable, single group. If it decides to go there now. Here we go. Oh, it's opening up in a new window. All right, so I'm going to enter the raw data. All right, so we had 7, 8, 10. What in the world happened? 7. It is not letting me type in there. Why? It is not going in there. I don't know. Okay, hold on. All right. Here's what we got. That's what I got for the summary statistics right there. N is 7, because we had 7 pieces of data. There's our mean right there, 12.856. What's the standard deviation? 4.375. Is that what we got? That's actually like substantially different if I think about it. 4.375. So let's figure out what happened. Here we go. 4.375 from Staplet. So I'm curious. If you take this 114.86, divide it by 6 instead of 7. 114.86. I want you to divide that by 6. We divided it by 7. And then I want you to square root that result. And tell me what you get. You said 4.375? So they were dividing by 6. We divided by 7. Why did we divide by 7? We had 7 groups, right? They divided by 6 because of something. We'll get into the why of it later on, but it's called degrees of freedom, and it's because we have a sample. You guys are not every single group of students here at Pike High School, so I don't have my information coming from the whole population. We're just doing a small little sample, and when we find standard deviation from a sample, we are going to take the summation of xi minus x bar squared divided by n minus 1. And then we will square root that. So what I have there where it says standard deviation from sample, the thing with the orange square root sign over it, this is the important takeaway for how we will calculate standard deviation. You're going to be using this quite a lot. I believe, and I'll double check this before we get too deep into the semester, I believe that you are actually given that formula to use on the exam. I'm almost positive. But if you guys have ever had formula sheets that you've been allowed to use before, hopefully you know that the important thing is not memorizing or not memorizing the formula. It is what do you do with it once you have it. You need to know how to use what you've got. Okay. So I want to look now at question number 6. I want to pretend for a minute that there was an 8th group in the room. And that 8th group, when I asked them for how many colleges their group was going to apply to, they said 40. Everybody in their group was going to apply to 10 different colleges. So we have this extra data value of 40 here. How is that going to affect the mean, the median, and the standard deviation? You guys okay if we just use some technology to calculate those summary statistics? Okay. So I'm going to hop back into where I had my data set. Sample size of 8. Let me hop out of here. And I'll put that picture up on the screen. All right. New mean. What is my new mean? 16.25. What's my new standard deviation? 10.416. And my new median? 15.5. I want you guys to copy those down for number 6. New mean, new standard deviation, new median. New mean, new standard deviation, new median. And we are 1 minute to the bell. So after you get that copy done, we'll finish this up tomorrow. Very quickly, guys, before too much noise happens, I want to make sure that we are all understanding about the homework, and I want to pass out the 1.3 homework. If you're having trouble uploading your assignments into Canvas, please see me. Please make sure that you get a new homework from me. This one is not due until Thursday. All right? 1.2 was due today, so come and grab a homework from me. Absolutely, you may. Oh, wait, okay. There we go. All right.